Another lesson, we got 5.5 exploring ratios. So grade 8s, I'm just going to do a quick review of ratios, and honestly, if you've done ratios in the past and you're in the know, this is going to be an easy one. But ratios are kind of tricky, and I want to show you exactly why. A few years ago, I had a kid, I'll turn this on so I can talk a little quieter. I had a kid in class, and he was helping out his friend. And his friend said, I don't quite get ratios. He goes, oh no, they're really easy. They're exactly the same as fractions. And I think subconsciously I was shaking my head no when I said it, because ratios and fractions are very similar, and sometimes they are almost alike, but they are very different. I want to show you why. So for example, I'm going to look at the ratio of girls and boys and girls to grade 8s. So let's see, we've got 1, 2, 3, 4, 5 grade 8 girls. We've got 1, 2, 3, 4 grade 8 boys in this lesson right now. So we have a total of 9 grade 8s. Well, if I've got 9 grade 8s and 5 girls, 5 out of 9 are girls, right? 5 out of 9 grade 8s right now in this lesson are girls. Okay, great. So I can say the ratio of girls to the ratio of grade 8s is 5 to 9. So if I said, what is the ratio of girl grade 8s to grade 8s total, you would say 5 out of 9. What is that? Then what do you think that ratio is?
Oh,
Yeah.
it's the boys?
Boys to girls?
Yeah.
So if I said, hey Johnny, can you give me a ratio of girl grade 8s in this lesson to boy grade 8s in this lesson, you can say 5 to 4.
Yeah.
Don't these look a lot alike?
Mm-hmm.
Those look like a lot alike. But aren't these numbers also telling the same story as this one? Aren't they telling a very similar story?
So, yeah.
They are, but they're not exactly the same. And I want to explain what the difference is. A fraction is one single number. This is a number. And you need the top and the bottom to make that number. And if I were to change the top or bottom, that would change what the number is. Like if I change this to a 3, the whole thing changes. But this is a number on its own. And this is a number on its own. This is a number on its own. And this is a number on its own. For example, let's say one of the boys went to the washer and was no longer here. Wouldn't that change the number to this? Now there's only 8 grade 8s in this lesson. But that's a completely different number, isn't it? 5 8s and 5 9s. Aren't those completely different? They're close to each other, but it's a completely different number. Well then, I guess the boys would go down to this. Did that completely change this number? No. There were 5 girls before, 1 boy went out. There's still 5 girls. I can change part of a ratio without changing the other side. But if I change the top or bottom of a fraction, it completely changes the whole fraction. Now this is kind of tricky. And I remember when I was learning math in university, and we looked at this and talked about this, I went, oh yeah, because I had totally forgotten how just 10, 15 years before that, I had learned this. But ratios are 2 numbers, and a fraction is a single number. It's 2 numbers working together as one number. Now let's see if we can get a couple of introductory ratios out of the way. On your board, I would like you to give me a ratio. I'd like you to look at the grade 7s out and about the room, and I'd like you to write down a ratio of girls to boys in grade 7. So take a moment and look, girls to boys in grade 7.
Wait, there's only 4.
Once you have a number,
Wait, no, it's like this.
you want a ratio of girls to boys.
It's 3 girls. And 3 boys. 4. Where's the 4th?
Okay,
I can't see. Oh, I can see Frankie, eh?
there we go. So how many grade 7 girls do we have?
4, 3.
We have 4 grade 7 girls right now in the room.
Yeah.
How many grade 7 boys do we have in the room?
3.
4. I see 4.
There's only 3 three. DR doesn't count.
1, 2, 3, 4.
DR doesn't count.
I'm talking.
Oh,
Okay.
yeah.
Like this?
Yeah.
Okay. So let's do this as a ratio then. I see some of you have this. Girls to boys or boys to girls, right? Okay, great.
So 1?
Great. Now, I'm going to go back in time in my mind to that kid who was helping his friend out and said, oh, no. Ratios are easy. They're just like, it's the exact same thing as fractions. Okay, so could I say this, boys to girls?
Yeah.
1 whole.
No, but you need a total.
Because this says that if this is girls on the top, that means there's 4 girls for every 4 people in the room.
Yeah, I saw.
This means there's 100% girls in grade 7 in the room. Are all the grade 7s girls in this room? No.
This.
So this is correct, but this is not. That's 100%. That's 1. That's 4 out of 4. That means 4 out of every 4 people. Not the same. Now I want to try something different. I want you to write a ratio of grade 7 girls to grade 7 students.
I got it.
Thank you. Yes. Yes. Now careful, remember a ratio is not a fraction though. A ratio is not a fraction. Thank you. Okay, so this is grade 7 girls to grade 7 students total. Could I say 4/8 of the 7s are girls?
Oh, what half?
Or half of the 7s are girls? I think.
Yeah.
So in this case it worked, but right now it's correct. But I don't want you to confuse yourself with that, because a fraction and a ratio are 2 separate things. This is one number combined. Half of grade 7s are girls. These are 2 completely separate numbers. So even though this is correct, please don't use it when we talk about ratios. We should always use that colon, those 2 little dots. And why is it a colon? I'm not exactly sure. I'll have to explore that further. All right, let's do some quick ones. In your textbook, 5.5. There's different ways to compare numbers. Look at these. 2 out of 3 people survived.
People surveyed.
Surveyed. 2 out of 3 people surveyed preferred Super Popper popcorn.
Super poppers.
So 2 out of 3. I want you to write a ratio for this. 2 out of 3. Now I've got 2 possible ratios that you can put on your board. That's one of them. That's one of them, yes. Oh, interesting. We'll come back to that. Okay. Now, can I get you and you to hold your boards for your friends? I want you to show them. This is one possible ratio. And that ratio, 2 out of 3 people. So this is the total people surveyed, and 2 of them prefer. Can anyone find the other ratio that you can write for this?
2 out of 3. So.
What do you think?
Oh, 1.
Interesting. Okay, I'm going to write the suggestion down. This isn't the one I was thinking of.
4, 6.
Yeah, I
4,
was trying to say
Oh,
that.
okay, I like that.
I was
Let's
doing
go
that.
4 and 6. I don't even know if this is on camera, so I'll just make sure. Okay, so
Yes.
4 out of 6.
Wait, not 2/5.
Okay, let's take a look at these. So Johnny shows me this. What's Johnny thinking right now?
Oh, like they add both of the numbers.
Ah. But what's the 5 represent then?
Everyone.
How many people were surveyed?
5.
Oh, 3.
Only 3.
Oh,
So this one represents a number, but this one doesn't accurately represent. How about this one? Is this one okay?
Yeah. It's just times 2 so you can get a reference.
Times 2 times 2. This is an equivalent
I
ratio.
was trying to do that on here.
I was thinking this. I want you to think about this. Now hold on. Okay. Now, I don't want to bring any kids on camera because this goes on YouTube. Apparently a bobbing camera YouTube.
It already got me, probably.
But let's say I interviewed these 3 people here, okay? This guy He likes the Super Popper popcorn. She likes Super Popper popcorn. He likes Orville Redenbacher.
Oh yeah.
Now, look at these three. Super Poppers, Orville. I think you just like the bow ties.
Super Poopers and Orville.
Can you see my ratio now?
2-1.
2-1. So if I surveyed you guys, what's the preference, Super Popper or Orville Redenbacher? Well, Super Popper wins 2-1. These are all correct ratios representing that. Let's see if we can come up with two ratios for this. 7,036 out of 1,554 people surveyed preferred Super Popper popcorn. I want you to see if you can come up with two ratios to represent these numbers. Two ratios to represent these numbers.
No way. Hey, 736.
Yes, I agree. You're trying to do the math in your head right now. I can see it. I can see it. Here, I'm going to do some of that math on the board for you. I'll help you out, okay? Can you stop with the noise that isn't math related? Does that help you out there? A little bit? Can you think of the other one? You've got one. You've got one for sure. You've got one, yes. So everyone has